Hello friends, welcome back. I had got a request to make a video on the acid property of a transaction, or you can say the acid property of a database. So in this session, we will understand what is acid property of a transaction. So in a database, everything about transaction. So we use the database to, either to stores the data, to process the data into the database. So storing the data means we are doing some transaction and storing the content into the database. So transaction is a single logical unit of work which access and possibly most of the time we modifies the content of a database. So in order to maintain the consistency and integrity in a database, the before and after the transaction that you have done, certain properties are followed by which you will maintain the consistency and integrity. And that properties are called the acid properties. So the acronyms of the acid is A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. So we will go each and every of the acronyms of that acid property, and we will see and understand with an example how the acid property works and what is all about the acid properties. So guys, you have come to my channel first time, please subscribe and like my channel. So the first acronyms of acid is atomicity. So atomicity, atomic, right? So atomic is, an unit. So a transaction is an atomic in nature, means either the entire transaction will take place at once or will not happen at all. So there is no midway, there is no partial transaction, nothing. Either it will success or it will fail. So this is called the atomicity. So let's understand with an example. What does it mean? So let's say you have a two account, okay, X and Y. And if you want to transfer the 100 amount from the X account to the Y account. So there will be a single transaction will get initiated, transaction T, which will debit the 100 from 100 amount from the X and will credit the 100 amount to the Y. So to debit the 100, there will be a T1 transaction, and to credit, there will be a T2 transaction. So first, to debit the transaction means to minus the 100 from 400. First, we'll have to read the value of X. So I'm reading the value of X. Then whatever the amount we are going to debit, we are minus. So we will minus 100. So now the X will become 300. And now the 300 we are writing to the X. So now X will become the 300. So after X, after T1 execution, X become 300, right? So once the debit happened, once the T1 transaction completed, now the T2 will get executed. So first we'll read the value of Y, 300. And whatever you have minus over here, we will be adding over here in the Y account. So Y plus 100, and you will write this. So after writing, Y will become the 400. So if you see, this is the atomicity. Either if your T2 transaction is getting failed, then it will not be a consistent, right? Because X is now 300 and Y is now 300. It could not, credit the 100 rupees, right? So it will be not consistent, right? So if T2 is getting failed, T1 will also roll back and it will maintain the state whatever it was. So it will be 400 and 300 only. If any of the transactions T1 and T2, either of that are getting failed. So this is the atomicity. Either the whole transaction will get passed or will not happen at all. So this is called atomicity. A stands for atomicity. Now C for consistency. This means that integrity constant must be maintained so that database is consistent before and after the transaction, right? So before and after the transaction, if any transaction are happening, it should be consistent. So it should maintain the state, right, of of that database. So let's say in our previous example, if you see, uh, before T occurs, the sum of the two account was 400 plus 300. If you go back, so if you see here, before transaction 400 plus 300, if you sum up, it will be a 700. And after the transaction, if you see 300 plus 400, it will be a 700. So before the transaction and after the transaction, it is maintaining the integrity, right? So 700 before and after 700. So it should maintain. It should not happen like, the before 700 and after, after transaction occurs, it is becoming the 600. No, it should maintain the integrity, right? So this is all about the consistency. Now, next is I from acid. So I stands for isolation. So isolation ensures that, if the multiple transactions can occur concurrently without leading to the inconsistency of a database state. So in the case of, multiple transactions are happening on that account, on that particular table. So without leading to the inconsistency, it should maintain the database state. So transactions should occur independently without interference. So in a one account, suppose you are debiting the account from the ATM card or crediting the account from the net banking, or you are trying to uh, make the payment from the wallet. So at the same time, if there is account is attached with the multiple, customer, like in minor or family member attached with that customers, so it should maintain and it should have independently without interference. So let's understand with the help of example. So let's see, you initiated T1 transaction and you have a T2 transaction, right? So let's say X account is having 500 and Y account is having 500. So consider two transactions, T1 and T2 are happening. So T1 started read the value of account X, and after reading, it's multiplying 100. So 100 multiplied by 500, it becomes the 50,000, right? And write the value of X now 50,000 to the database, to the X. And again, it started reading. And after reading Y, it switched to the T2 transaction. It could not read the Y and the write Y. So here, reading X. So reading X will be 50,000 because we have write X value over here, and read Y. So if you are reading Y, it will be a 500 because we have not, this value has not got updated minus 50. So it will be still 500. So 500 X value is 50,000, Y value is, okay, what? It should have 450, right? But it's now, as of now, it's what is the value? It's a 500 only. And writing to Z. So if you writing to the Z, what will be the total value? If you see here, 50,000 plus 500, it will become the 50,500, right? But in the case of this X plus Y, 50,000 plus 450, right? Then what happened? Now after T2, okay, we are doing this, and then after again executing this line, Y minus 50. So Y will become what? 450, right? So 50, 450. So if you see both the transaction, this is the inconsistent. So T1 is having 50,500 and T2 is having 50,450. So this should be have maintained. But however, since this is not have minus yet, so this will be the some different value, right? So this is the inconsistency. Now D stands for durability. So durability, you can understand in a way, like if there is any software failure or any software failure, like your machine is getting started, your server is getting started, it should maintain the state. It should remain, data should remain as it was if the data has been committed to the database. Let's say, of account X of Bob is having containing $100. This information should not disappear upon system or system failure or software failure. So it should durable, right? It should not depend upon the either your RAM is getting crashed, or even the hardware is getting crashed because you have maintained the rack of the database. So the account X value should be maintained even though your system are getting failed or software are getting failed. So guys, this was all about the ACID properties. Please subscribe, like, and share this. So some people feels like this is all about question or asked in data interview, but this is not true. This question is very important even in the Java interview, .NET interview, or even in the Python interview, whichever application is communicating with the database. The main problem is to maintain the consistency of the database. So ACID properties try to resolve the problem of the transaction with maintaining the atomicity, consistency, integrity, and durability way. So thanks guys, thanks for watching this channel. See you in the next step. Bye bye.